Hi, in this video, we will learn about conditional statements and propositional equivalences. Many statements, especially in mathematics, are in the form of if P, then Q. Okay, so statements like this are called conditional statement and denote by this symbol, if P, then Q. If P, then Q is frequently read as Q when P. Also, P implies Q. Or you can also read this as P only if Q. Now, look at the truth table for the implication. Okay, this is the implication. P implies Q. So in this case, you earn an A in logic. This is your P or your hypothesis. And then another sentence, I will give you a present. This is your Q or your conclusion or consequence. Okay, so the first row naturally follow the definition. This is the first row. P true, Q true, then P implies Q must be true. The second row false because Q didn't immediately follow P. So this is false. And then row number 3, you will get T because it doesn't invalidate the original statement. And the last row, if P false, Q false, then this is true. If you didn't earn an A in logic, then I will not give you a present. Okay. So for implication, conditional statement is true in all but one case, which is the first statement true, then the second statement false, you will get false. Otherwise, it will be true. Another common statement is of the form P if and only if Q. These such statements are called biconditional statements and are denoted by this symbol. Okay, if and only if. Okay, so now look at example. So you can take flight if and only if you buy a ticket. And then you can have dessert if and only if you finish your meal. So the truth table, whenever the two statements have the same true value, the biconditional is true. Okay, true. Otherwise, it is false. Okay, there are many alternative ways to state P if and only if Q. Okay, so P if and only if Q. Okay, you can also write P is a necessary and sufficient condition for Q. P I F F Q. And you also can write as P implies Q and Q implies P. All these 5 have the same meaning. So look at number 5. P implies Q and Q implies P. So you know that this is P if and only if Q. So this is equivalent to P implies Q and Q implies P. P if and only if Q is equivalent to P implies Q and Q implies P. Okay, so you can prove this by using the truth table. Okay, so now look at converse, inverse and contrapositive. What we have learned just now, P implies Q. If it is raining, then the home team wins. Okay, so what is converse? Converse of P implies Q is Q implies P. So that means the converse of the implication is the interchange. You have to interchange the hypothesis and the conclusion. So that is converse. The next one is inverse. The inverse of the implication P implies Q is negation P implies negation Q. So you just take the negation of both statements, P and Q. So for the implication, if it is raining, then the home team wins. The inverse will be, if it is not raining, then the home team does not win. And the last one, the contrapositive of this implication, P implies Q, is negation Q implies negation P. Okay, so we just interchange the hypothesis and the conclusion of the inverse statement just now. Okay. Or you can also say that the contrapositive, you just have to reverse the roles of P and Q and negates each of them. So if the home team does not win, then it is not raining. Okay, so now let's move to another subtopic, propositional equivalences. The first one is the logically equivalent. Two different propositions have the same true value no matter what true values their constituent proposition have. Okay, so such propositions are said to be logically equivalent. Okay, so this is the symbol for logically equivalent. Okay, so you can see this. You have two different propositions. This one, negation P and Q, and negation P or negation Q. When you create your truth table, you can see that these two propositions are logically equivalent. Okay, the last value of your truth table is same. Okay, FTTT and FTTT. So that is what logically equivalent mean. The next one is tautology. Okay, tautology means a compound proposition that is always true, no matter what the true values of the propositions that occur in it. Okay, in the easy way, tautology means contains only T in the last column of the truth table. For example, P or negation P. P or not P. Okay, you get all true. So this is tautology. And another one is contradiction. Contradiction is a compound proposition that is always false. Okay, contradict to the tautology. Contradiction contains only F in the last column of their truth table. And the last one is the contingency, a proposition that is neither a tautology nor a contradiction. Okay, so this means a statement that can be either true or false. Okay, so in the last column, it has true and also false. So that is contingency. Okay, so that's all for today. Bye.